All right, today's video is going to take a look at the C-axis live tool lathe. This is the lathe that we have here in the shop at Lincoln Tech. So let's just take a look at some of the features that make this lathe a little bit different from our ordinary CNC lathes. So this is a ST10Y. All right, the difference being the Y-axis added to this machine. The ST indicates it's a slant bed. The 10 is the size of the machine, and the Y is what's unique about this machine, giving it one extra axis. So let's take a look inside the machine so we can see what's different in a live tool machine. So on our turret, we've got our ordinary cutting tools, several different stations for those, internal tools, external tools, as we would on any standard lathe. All right. What's unique about the live tool machine is we have another motor behind the turret. All right, and that motor can drive a spindle. So this is a spindle mounted tool. All right, so we've got a milling cutter in here, driven by a motor behind the turret. All right, and each live tool, this is another spindle up here that's a right angle tool. All right, so they have a drive mechanism on the back side of them. There's a drive shaft that's connected to this motor. So as the tool comes into position for cutting, it engages the drive shaft, and now we can have a milling operation or a right angle milling operation or drilling operation run off of the turret. So this works in conjunction with the ordinary turning operations and the ordinary architecture of the lathe. Where, as we recall, the Z-axis is moving towards the spindle, all right, through the center of the spindle, and the X-axis is the travel of the tool turret perpendicular to the spindle. So we had mentioned the Y-axis. The Y-axis gives us a little bit of extra travel in an angle perpendicular to the X-axis. It gives us a little bit of travel so that the turret can move across the face of the part. All right, that's what's unique about these machines and can give a live tooling lathe a little bit more functionality on the face of a part. All right, so we can do milling operations or drilling operations on the face of the stock. So how does this work? Well, the ordinary turning operations would be complete. The machine is holding the work in the spindle, and the spindle is your Z-axis. So we're going to use this as our work holding for our live tool operations. So the Z-axis now becomes our C-axis, all right, because we're no longer spinning the chuck, we're going to index the chuck. So we can lock it into a position, and then we can very accurately index it by degrees, and this is what we call a C rotation. So the other live tools can now work on the workpiece as if it were in a milling machine. So when we look at the G-code program for this job, we're going to see that it actually changes planes. So imagine if you were to take this machine and stand it on this end. All right, so that now the Z-axis is running vertically, just like it would run in a milling machine. All right, that's what changing the plane in the G-code program is going to do for us. We're not actually going to turn the machine up on end, but the control is going to view it that way. All right, so that we've flipped the axis of the machine so that now we're holding our work and approaching it with the Z-axis as the tool's mounted on the spindle. So now we've got an X-axis and a Y-axis, and our Z-axis is going to be the depth of cut towards our workpiece. So that's the unique features of a live tool lathe. The ability to lock the workpiece in the chuck and index it in degrees, around a C axis, and the ability to drive these tools from a motor behind the turret and actually do milling and drilling operations on the face of the part or around the perimeter of the part. So we'll take a closer look at the codes involved in doing this and the programming in a little later video. Thank you.